Good morning, everyone.
Good morning, ma.
Good morning.
Good morning.
Welcome to today's class. Before I go into what we have for today, can anybody give us a recap of what we did yesterday? Anybody who is willing to give a recap of what we did yesterday? Wow, nobody.
We looked at population, we looked at variables and constants, we looked at statistics. We also looked at types of variables.
Please, if you are not speaking, kindly mute.
And the 4 levels of measurement, which is the nominal, the 4 levels of measurement: nominal scale, ordinal scale, ratio scale, and interval scale. And we looked at center for in the mean, median. Okay, we stopped at mean, median, and mode. And we said that the mean average number, the mode is a recurring number, and the median is the median number. I'm trying to remember something.
Mimi, though, can you please mute? Mimi, though, please mute your mic. Rosemary, are you done?
Yes, ma. I don't know if you have a question to ask. We talked about descriptive and continuous variables, and we said that the descriptive and the continuous variables falls under the quantitative variables. And we talked about the 2 types of statistics, which is the inferential statistics and descriptive statistics. So yes, ma'am, done.
Okay, thank you. Well, you didn't go into details the way I expected. So are you willing to answer any question I ask?
Yes, ma'am, I will try.
Okay. So before I ask Rosemary any question, first of all, I want to say that please let's take our interaction in the class very serious, because this is a 3 credit unit course. The course is significant to your CGPA. It's also significant in helping you go on with your thesis very well. So you said we talked about population and sample yesterday. What's the difference between the two?
Difference between
population and sample?
Okay, population is the set of all the objectives that we wish to study, and sample is a part of the population that is studied to learn about the population.
All right, so the difference between parameter and statistic.
Okay, parameter is a summary of the population, the numerical summary of the population, while statistics is the numerical summary of the sample data.
All right, so statistics is divided into 2 branches. What are they?
Inferential statistics and descriptive statistics.
What's a variable?
A variable is any observation which can take a different value for different people, different times or place.
All right, so how many types of variables do we have?
Basically 2. That's qualitative and quantitative.
So under quantitative, what do we have?
Now quantitative, we have discrete and continuous.
What are the measurements for discrete and continuous? Level of measurement.
The measurements for
Discrete and continuous variables.
okay, is ratio scale for continuous and interval scale for discrete.
All right, so qualitative, what is the difference between quantitative and qualitative? Let me be sure you understand that.
Okay, quantitative variables are variables that are categorized. I've not missed it. Okay, qualitative variables are variables that are categorized, and quantitative variables are variables that are numeric, like the
You said quantitative are what?
numeric values. Quantitative variables are variables that quantitative variables are variables that have a numeric value.
Okay, so
Variables
level
that
of
take
measurement
numeric
for
values.
qualitative. What are the
Level of
two
measurement for
measurements for
quantitative
qualitative variables?
is nominal and ordinal scale.
What's the difference between the two?
Dif- the difference between nominal and ordinal scale.
Yes.
Okay, nominal and ordinal scale. I think nominal scales are used to measure variables without quantitative value, and ordinal scales are typically measures of non-numeric concepts like satisfaction, emotion.
All right, you have tried and you missed it here, but you have earned 2 marks for today's
Okay,
class already.
thank you.
So the difference between nominal and ordinal is that, just like the name ordinal, the categories are ordered. While for nominal, they are normal, they are not ordered. And then yesterday we talked
Okay.
about mean, which is the average of a distribution. We talked about median, the middle value. And when you have two middle values, you are going to add their values and divide them by 2. And we talked about mode. That's the observation that occurs most frequently. And we say in a distribution, if every data set has the same level of frequency, it means
I don't know why all of us
there is no mode. Is there any challenge, John?
Oh, man, thank you. Sorry.
So kindly mute, please. I can see Augustine, Fayam, Richard. You people are not muted. I hope you won't start disrupting the class. All right, so this is basically what we did yesterday, and I'm thankful to Rosemary. At least you have made me to understand that learning occurred. There was exchange of knowledge yesterday, so you have earned 2 marks for today. Well done. Today we are going to move into something else. So yesterday somebody said that I was not sharing my slides. So and I earlier on explained. So today I'm going to be sharing my slides. Okay. All right. Can you guys see my slides?
Yes, ma'am. We can see it.
Can see it.
It's up now, right?
Yes, ma'am.
Okay. So please, I want to encourage us all to participate effectively today. You never can tell. Your 1 or 2 marks might just be the difference between. And for MSc, okay, so I'm your exam officer. Before I go on, the pass mark for MSc is 50, unlike normal. We know for PGD is 45, for BSc is 40. But for MSc is 50, so you need to take the course seriously. So the extra marks you earn during the class might just be the difference between a fail C, CB, and BA. All right, so quickly today we'll look at so yesterday we looked at descriptive statistics. Today we're going to look at correlation, we're going to look at regression. If there is time and if I can. So I don't know if we'll be able to have another class, but if not, the person I'm taking the course with will take the remaining topics. But I do hope that we'll be able to come for revision physically in school so that I can expose you people to the software are intended to teach you people. At least you should learn how to import data, learn how to do basic descriptive statistics, and then to export your results. But if not, then maybe we'll just have a virtual revision close to examination. Is that okay?
There will be.
Yes, ma'am.
All right. So upon completion of my class today, students are expected to understand and describe various statistical methods, and you should be able to develop analytical literacy and statistical skills. They'll help you implement research. So
Excuse me, ma.
yes,
Please, can you make your slides a bit bolder?
really. When you say bolder, what do you mean?
It should pop up on the screen more than it's too tiny on the screen.
It's too tiny on the screen.
Yes, ma'am.
Okay. How about now?
It's fine now.
It's okay,
It's fine.
All right. Okay. So let's go into correlation. Now, upon completion of this lecture, students are expected to define correlation analysis, identify types of correlation, explain types of correlation coefficients, calculate and interpret Pearson's correlation coefficients, and analyze real-world data. What is correlation? Correlation is defined as the statistical association between two variables, right? So in real world, it's possible that some people can claim that they are friends, but they're actually not friends because the association, when they are friends by lips, but they don't show it with their action. So it's possible for us to see two variables and there will be no association, right? It's possible for you to see a couple, you would think they are husband and wife, but the relationship is not significant. As we go on, I'll explain, but I like to use real life experiences to explain. So for example, we can say for two friends in this class, we can say there's a positive correlation between two of them because their association is strong. That's what correlation is about. Correlation analysis is a statistical technique used to determine the strength and direction of the relationship between two variables. So we might have two people in this class. It is expected that maybe because you're in the same class, there's going to be association, but we might check and see that there are two people that don't like themselves in this class. If one person is going north, the other person is going south. So we can say they have zero correlation. But for two persons who are always on the same page, they have the same ideas, we can say that the correlation between the both of them is what's strong. So correlation checks the association between two variables. Now we say statistical association because it is possible for people to the relationship between people to look strong, but it might not be significant. An example might be a couple, maybe a husband and wife. You see them posting themselves on Facebook, you say, these people are very tight, but at home they might be beating themselves. So there might be strong, the public might perceive that they have strong association, but that strong association is not significant, right? It doesn't translate to real life. It's just window dressing. So it's possible that there will be association between two variables and that association might not be significant. It is possible that there will be association and the association might be significant. So there are two different things. That you have an association does not mean it is significant. You can now go further to check whether this association is significant or not. Do we understand?
Yes, ma'am.
Yes, ma'am.
All right. So what's the importance of correlation? Correlation helps us to identify patterns and relationship in data to inform decision making. So yesterday we talked about statistics being divided into two groups. We said descriptive statistics and inferential statistics. Examples of methods we have under descriptive statistics include mean, percentages, median, standard deviation. So there's, I told us of instances where you can use mean to make a decision, where you can use median to make a decision. There are sometimes that mean, median, mode would not work. You might use standard deviation. I think Dr. Ali is going to cover that, but if it doesn't, maybe during the revision. So there are, for example, you go to a school and they say, in 2025, average JAM score in this school is 250 or 300. And you might just conclude that this is a good school, but you are not looking at the fact that you might have exceptionally gifted students. So if you're looking at the mean now, you have made the conclusion that this school is a good school. But if you go further to look at the standard deviation, so the standard deviation looks at the difference between each person's score and the mean score. So for example, if the mean score is 250, how many people score around 250? Let it not be that you have people that have 120, 110, but you have a lot of people that have over 300. But when you add the average, it takes us to 250. So if you're using the mean now, that means you have few exceptional students that have raised the mean up. If you're using the mean, you'll be misled that, oh, this school is a very good school. But when you look at the standard deviation looks at the difference between each person's score and the mean score. So if the standard deviation is large, then you can say, no. There are other factors that has made them come up with this average. It's not like the school is, as good as we think. We have exceptional students and what have you. It's not like there's something unique about their teaching. So for each of these, there are scenarios where you can use mean, you can use median, mode, and what have you. Now let's go to inferential statistics. Correlation falls under inferential statistics. Regression falls under inferential statistics. And under regression, we have lots and lots of branches. But now we're looking at correlation. Correlation looks at association, statistical association between two variables. I remember that correlation might be 0. That means these people, they don't see themselves eyeball to eyeball. Correlation might be weak. They are just there. And when they say divorce is not good, we are just there managing ourselves. It's not like there's really anything. We are just hanging by the ropes. Correlation is weak. Correlation might be strong. You see them when they're going out, they are wearing ashwebi, together like that. But we can still also go further to check this correlation we are seeing. Is it actually significant? I hope it's not window dressing. So correlation, we have them in those stages. Is that understood?
Yes, ma'am.
Yes, ma'am.
Please, if there's any question, kindly take me back. All right, now, so the first place to even start before we check for association between two variables and what have you is a scatter plot, right? A scatter plot is a graph of the paired X and Y sample data with a horizontal X-axis and a vertical X-axis. Let me see if I can connect my graphic board. So when we say the first point to start is with a scatter plot. Okay, I think I have pictures here. So let's go. A scatter plot is just a graph where you have X and Y axis, and then you plot your paired sample. So if you want to check the relationship between two variables, it means they are paired. So let's assume that one is X, another one is Y. One can be John, another one can be Abu. X and Y is just a name we are giving the variables. They can be anything. So each individual XY pair is plotted on a single plot. So this is an example of a scatter plot, right? So this scatter plot is telling us, this is a scatter plot of chest G versus length, right? So this scatter plot is telling us that there's a relationship between chest G and length. And we can see that the relationship is going towards the right, is going up. So we can now go further. From this graph now, we can say, it looks like there's an association. We can now check using correlation. But if the points are just scattered around, there's no point going to even check for correlation. It tells you that there's really no association. So you have one point close to 60, another one close to 20, another one 40, just scattered, filling the whole screen. But from this way, we can see a pattern that is, ascending upward towards the right. Is this clear?
Yes.
All right,
Yes,
so
ma'am.
from the scatter plot, the scatter plot gives us an insight that yes, there might be something between chest G and length. We can now go for that to use correlation. Is there anybody that doesn't understand this? So we see that the points are close to each other and they are moving towards, so there's a pattern, it's moving upward. Can we all see that pattern?
Yes, ma'am.
But if the points were scattered around the screen, it tells you that one person is in Sokoto, another person is in Benue, one person is in Benue, another person is in Lagos. It's just scattered. You really cannot pick a pattern. But here we can pick a pattern. We can draw a straight line going up. So from the scatter plot, so when we say we start first at the scatter plot will give you insight, idea whether to, if you see that it is scattered from what you're seeing visually, it tells you that there's no relationship, there's no even point going to correlation, but you can also go to correlation to confirm what you are seeing in your scattered plots.
Ma.
Yes. You'll
Okay,
be.
ma.
We're all
The
ears.
statistical background. Yes, ma. Can we be right to say? Okay. Can we be right to say this scatter point is some sort of a graph showing the possibility of a correlation or not?
And no, the scatter plot gives you it gives you an idea whether there's a pattern, right? So we can't just conclude with a scatter plot, but from this scatter plot, we know that there's an association between chest G and length, and then we're going to go further to
Hear me?
correlation to confirm our guess. You said what?
Excuse me, ma'am.
Yes, I'm all ears.
Please, not like I'm taking you back, but from the notes, this was not where we stopped, so I'm kind of confused.
Who is speaking?
Mimido, Abu Mimido.
So where did we stop in the notes?
From the notes we're following, it stopped at the mean mode and media, so I don't know.
So this is what I'm teaching you today now. I'm done with that.
Okay.
So this is a new topic I'm teaching. Are you just joining the class?
Yes, ma'am.
You're just joining. So this is what, so are you expecting that I'll still continue explaining what I did yesterday? So we are moving on. We've already set the foundation. We're moving on to higher things, leveraging the foundation we set yesterday. So today we are looking at correlation. And I say correlation checks the statistical association between two variables. And we say before we even go further to correlation, the first point to start is plotting a scatter graph. If we were in the school, in the computer lab, all of us would have just done a scatter plot. It's something very easy. Who is talking? Hello.
Okay, ma, it's noted. Thank you.
All right, so we say before you go on to correlation, the first point to start is a scatter plot. When you plot your two variables on a scatter plot, it gives you an idea whether there's an association. You can check whether there is a pattern. So from what we have now, please, can the person talking mute? From what we have, we can see that there's a pattern between chest G and length, right? So we can see that the variables are not too far from each other, and it looks like they are all ascending towards the right. So the scatter plot gives us an idea that yes, chest G and length might be correlated, but we can now go further into the correlation proper and check, if they are correlated, is it weak? Is it average? Is it strong? If it's weak, average, or strong, is the correlation actually significant? When we say something is significant, yes, it should command our attention. If it's not significant, then it's something we can wave aside. So now we're going to, there are different types of correlation. We have positive correlation and we have negative correlation. We have, so the first one is linear correlation, and under linear correlation, it can either be positive or negative. We have the non-linear correlation. We have no correlation. When we say linear correlation, it means it is checking the relationship between two linear variables. And when it is positive, I have examples of graph to show us when it is negative. Non-linear correlation, this means there is a correlation, but it is not straight. Just like the name, non-linear. Maybe it is zigzag. Are we following? Hello?
Hi, ma.
Are we following at all?
A bit fast, so we didn't follow it
Not
like
really,
that.
ma.
Oh, so where did I lose you guys?
So you're trying to talk about the positive correlation and the negative correlation. So if you can start from there.
Okay, so I say we have different types of correlation. The first one is the linear correlation. But I asked you people if I was fast yesterday. Nobody even think that I was fast now. And I know that I'm a fast talker. So we have the linear correlation. When we say something is linear, it means it is straight, isn't it? From normal English. I'm not getting your feedback.
Yes, ma'am.
Okay, so
Hello, ma.
we have linear correlation. It is checking the association between two variables that are straight. And under this linear correlation, it is either it is positive or it is what? Negative, right? Then we have nonlinear correlation. It means there's association between the variables, but it is not straight. Maybe it is a zigzag pattern. It could be any pattern, but not straight. So that is why it is nonlinear. We also have no correlation. No correlation means there is no association. We can, in this life that we have come to, nothing can join us. No correlation. So, for example, two arch enemies, right? It's not like our politicians that will say we'll be fighting for our politicians and then they will go and dine together. No correlation means nothing can join you, right? So, arch enemies, there's no association at all. Is this clear?
Yes, ma'am.
Is there
Ma,
anybody that doesn't understand the different types of correlation?
Yeah, it's now that you have come to limelight. On your slides, I'm seeing types of relationship instead of seeing types of correlation. But now, as you have explained, I've come to understand that you are talking about types of correlation. Thank you, ma.
Oh, okay. Thank you. Well, they are all relationship, but your point is noted. Before I send you the slide, I'm going to change this to types of correlation. Thank you very much.
Thank
So
you.
any other question?
Justice.
Hmm? But another word, just so you know, correlation is relationship. We want to check, is there relationship? Is there association? They are like synonyms, but for the sake of clarity, I'm going to change this before I send it. All right, I can see Gemga's hand up.
Good morning, Ma. Ma, I'm not clear about the positive correlation and negative correlation. Please, Ma, throw more light there. Thank you, Ma.
Sorry, it looks like I lost you guys. I don't know at what point.
After Gimgia question.
I didn't even hear his question. Sorry, Gimga, can you take your question again?
Types of correlation.
He said you
What's the
should
question?
He said you say positive correlation and negative correlation, that he did not understand what the negative correlation, that you should explain them better for him. That's what he said.
For
Okay.
us, not just him.
All right, so it's in front. Don't worry. It's part of what I will say explain further, but I just wanted you to know that these are the types of correlation or relationships we have. Any other question?
I have a question.
Okay.
Thank you. Good morning. My question is, considering the types of correlation I have, the linear and non-linear correlation, I actually understood it well. But my question is, since the linear is actually a relationship between variables on a straight line, and then the non-linear is actually the ones that actually not really straight, maybe zigzag or so. But my question is it possible for someone to have a variable that's actually mixed, maybe in the course of a research or maybe a statistical analysis or something? The variable actually
What do you
starts
mean by
mixed.
mixed? What do you mean by
So
mixed?
the variable actually starts in a linear way, but actually ended in a non-linear.
And then it's non-linear now. As long as it's not straight, it's non-linear.
Okay. All right. Thank you.
So you said if the variable starts in a linear and ends in a non-linear, it can just be categorized as non-linear, right?
Okay. Right, thank you.
So we're going to move. Can you still see my screen?
No more.
Okay. How about now?
Yes, ma'am.
Okay. I'm sorry.
We can see it now.
You can see it now, right?
Yes, ma'am.
Okay, so we'll now be looking at we'll go further into, so something is actually blocking me myself. Let's shift this. All right. So types of correlation. Now, somebody say I should explain positive correlation. Positive. So whether you see relationship or correlation, I said correlation means relationship association. So please just pardon me, right? So under the positive correlation, positive relationship have points that incline upward. So let me go back.
No, na MTN. That means that clock get issue.
Who is saying now glue gets issue? Right. So for positive correlation, you can draw a straight line from the zero base upward. Can we follow? Or are we following?
Yes, ma'am.
So there's a graph that will show us. For the positive correlation, as the value of X increases, the value of Y increases. Right? So as the husband loves the wife, the wife loves the husband. As the love for the wife decreases, the love for the husband decreases. Any direction you want us to go, we go. So that is a positive correlation. Is this clear? Hello.
Yes,
Yes,
ma'am.
my
We are
clear.
following, ma'am.
Are we actually following?
Yes, ma'am, we are.
I'm not getting this thing from today's class. Okay. So I say for positive correlation, as the value, remember you have your y-axis and then your x-axis, right? As y increases, the value of x also increases so that they are going upward straight that way. An example is plant height typically increases as diameter increases. So we can say there's a positive correlation between plant height and plant diameter. Is this okay?
Yes, ma'am.
Yes, ma'am.
Please, if you don't understand positive correlation, let me know. Because I can bring out graphs and ask you to identify the type of correlation in each of the graphs. So this is what a positive correlation looks like. You can see that these X dots, they have moved from the point 1 up to the point where we have 5. So you can see that it's moving towards the right. You can draw a straight line up. So this is an example of a positive correlation. So when you have a graph with the diagonal moving from 0 upwards, we can say that it is a positive correlation.
Understood, ma'am.
Is there anybody that doesn't know what a positive correlation looks like? That means we all know what a positive correlation looks like, right?
Yes, ma'am. Yes, ma'am.
So if we see a graph with a line moving from the 0 part up, just going straight upward diagonal, we can say that the relationship between the variable, whatsoever they are. So in our own instance, the relationship between height and diameter is positive. Well, the fact that it's positive, remember I said that it can be positive and significant, it can be positive and not significant. We'll get there. But at this level, we can say that there's a strong relationship or strong association between the height of the plant and its diameter. Is this okay?
Yes.
Yes.
All right, so let's go to negative correlation or negative relationship. In negative relationships, we have points that decline down towards the right. So for positive correlation, the line starts from 0 and goes up. But for negative correlation, the line starts from, so for example, we know how y-axis is. So y-axis, you have 0, 1, 2, 3, 4, 5, 6, 7. Let's assume that the highest you have on y-axis is 10. For a negative correlation, that line will start from that point where there's 10 and be going down. So it is the opposite of positive. While positive is going upwards towards the right, negative is coming downwards from the right towards the left. Are we following?
Yes, ma'am.
And for negative correlation, as one increases, the other one is decreasing. As one decreases, the other one is increasing. So husband that doesn't love wife, wife loves husband. The kind of correlation we have between the two of them is what? Negative. Because one is loving one, the other one is not loving it. When the other one is not loving, one is loving. So it is negative. But in an instance where husband loves wife, wife loves husband, we say it's positive correlation. When it is one person that is loving and the other person is not loving, we say it is a what? Negative what? Correlation. Is this clear?
Yes, ma'am.
Yes,
ma'am.
Please, if you don't understand,
you must elaborate. Actually, you must elaborate because I was thrown out by the network. I've just rejoined and I was trying to understand what negative. But then your illustration was over, so it will be appealing if you go over it again. Thank you.
Okay. So if you not even remember, because I know that we Nigerians, we love relationship. That's why I love to use relationship to explain. So it drives home the point. Now, positive correlation is an instance where as husband loves wife, wife loves husband. It means the line between the husband and wife is moving from 0 upward. Are we following? But for a negative correlation, it's a situation where husband loves wife, wife does not love husband. Or wife loves husband, husband does not love wife. As one increases, the other one decreases. So we say it is a negative correlation between the husband and wife. But in a situation where as the husband loves wife, the wife loves the husband, it is a positive correlation. As X increases, Y increases. That is positive correlation. For negative correlation, as X increases, Y decreases. When Y repents and says it wants to increase, X will decrease. Are we following? Is this clear now?
Yes.
So an example is as wind speed increases, wind chill, and then temperature decreases. So when one thing is going up and so you can just look at life and just check different relationships. You'll be able to say whether it's a negative. Is there any challenge? Any question?
Yes, ma'am. I have a question.
Okay.
So when both their love for each other is matching, what type of relationship is that?
Please, who can answer him?
It is
Positive relationship.
Mr. Jigba, are you
positive
clear?
relationship or positive correlation.
Okay, that is where both the man and the wife love each other strongly. It's a positive correlation.
Yes.
Now, when the wife loves the husband, that is a negative correlation. The husband does not love the wife.
Oh my goodness, love is conceived officially in the class today.
And the husband did not return the love.
That is what is called negative correlation.
It's a two-way traffic. That means when the other partner loves the other and the other one does not love the other, is positive.
Negative. That is negative.
That's negative.
Okay, thank you, ma.
No, Mr. Jigba, please explain to me positive and negative correlation. Let me be sure you have gotten it.
Yes. Well, that's why I was, the whole thing was obnoxious to me because I wanted to know if a husband loves wife, that is positive.
That's
negative. The wife.
See, correlation, two people must go. If husband loves wife, what happens to the wife's love for the husband? If husband loves wife and wife loves husband, then it is positive. It's not one-sided. Are you following?
Okay.
If husband loves
Yes,
wife
ma'am.
and wife loves husband, that is when you say it is positive. Because as one is going up, the other one is going up. If the love is 50 for a husband's love for wife is 50, wife's love for husband is 50, husband increases to 70, wife too increases to 70. As it's going up, as one's love is going up, the other one is going up. That is when it is positive. But when the man loves the wife, but the wife is putting eyes somewhere else, he does not love the husband, it is negative. Are you understanding?
Okay.
Because
Yes, ma'am.
he's not getting reciprocate love back from the wife. When you get reciprocate love back, it is positive.
Okay. I've gotten it now, ma.
So, Gwakia, I can see your hand up. You can speak now, please, Gemga. Gemga, unmute and speak. You might be speaking and then your microphone is mute.
She's just citing an example on husband and wife. She's just bringing it to our real life so that we understand. Okay, it's MSC, Master's Class.
I don't understand. I'm lost too.
This woman now, she's lecturing with one other man.
Someone else.
If she's not around, she's just.
Please, which conversation is going on in the class? I'm lost.
I think the person is just trying to explain to somebody else what is happening in our class.
Okay. So, let me ask, Mr. Jigba.
Yes, ma.
So, what is the correlation between you and SST 807?
The relationship is not too positive. It's a partial.
Oh my goodness, Mr. Jigba, we've only talked about positive and negative. Which one is not too positive?
No,
So as
something in between.
we're advancing with SST 807, you are not understanding. That's what you mean by it's negative. Is that what you're saying?
Yes, ma. Yes. No, I'm not that I'm not understanding. I'm understanding, but then there are some things that are hindering my understanding. So
what
it's
are those factors?
Maybe you give more illustration so that I may assimilate more.
Okay, no problem. Okay, so let me think of another illustration. So another illustration. Okay, can somebody else help me? So let me hear you guys think. Can somebody give another example beyond love now on positive or negative correlation? Anybody in the class? Oh yeah, it's time to end marks. Let me be sure that we are all on the same page. So let's listen to Jennifer Jato.
Good morning, ma.
Good morning.
Good morning, colleagues. For negative correlation, I'm looking at, let's use age, for instance. As someone is growing old, their immune system is dropping. Their strength is dropping. So I think that's a
Do we
negative
understand what
correlation.
Jennifer is saying? She's saying the correlation between age and immunity is negative. The older you get, the lesser your immunity. And I can't even agree less. She's correct. All right. So, Jennifer, you have earned 1 mark. Mr. Jato, do you understand it better? Sorry, Mr. I said Jato, sorry. Mr. Gigba, do you understand Jennifer's illustration?
Yes, ma.
So, what is the relationship between age and immunity? What type of correlation is there?
negative correlation.
Why did you say it's negative?
Hi. Jennifer must explain back that thing because I lost out.
Okay, Jennifer, please, can you kindly
I can give
explain again to
another
us?
example for
Oh,
him
let me help
see if
Viva,
he can
please.
understand.
Hold on, hold on.
Help.
Jennifer, please, can you explain to him? Don't worry, we're
Let
going
me
to take my examples. Jennifer,
me
can you
also
please
assist.
Mr.
explain
Jigba,
again?
Mr. Jigba, are you online now? Hello, Mr. Jigba, are you online?
I'm online, yeah.
Okay, and your network is okay now, ba?
Yeah.
Okay, I'm saying for negative correlation, we can use age and immune system, for instance. The more advanced someone goes with their age, the weaker their immune system becomes, the weaker they become, even with their strength. There are certain things that when you grow old, you will not be able to do again because you no longer have that strength to do those things. Maybe you used to walk 5 kilometers when you were young, but as you are growing with age, your bones become weak, your immune system become weak, and you will not be able to make it 5 kilometers. Maybe you will now drop to maybe 3 kilometers or 2 kilometers. If you do more, maybe it's 3 kilometers. So that's negative correlation. Do you understand now?
Yeah.
Ma, I can give another example
Okay.
for him if to understand.
Let me give another example.
Okay.
My hand is up.
Mr. Jigba, do you understand Jennifer's illustration?
Yes, ma'am.
So,
I
Doc,
So that's a
understand that.
perfect
also help
But
if
example.
I
you
give
are
another
young.
example so that he will understand better.
Hold on now. So, Mr. Jigba, that's a perfect example of negative correlation. In negative correlation,
Okay.
as one variable increases, the other one decreases. All right, so let me
Okay.
check for someone that has not spoken.
Peter is here.
Eunice
Manasseh
have not
have not
spoken, no. Eunice
Okay,
have not
let's hear
spoken.
from
Manasseh have
Unisa.
not spoken.
Unisa, let's hear from you.
Manasseh have not spoken.
Okay, good morning, all. Like the other example that I may like to use, if you understand one, just like a magnetic field, North Pole, or South Pole, they repel. Why North Pole and South Pole they compare? So North Pole and North Pole just like positive correlation. They come to hello.
Sorry, please, can you start all over? I lost you.
Unisa, your example is too scientific. Jigba won't understand you.
Unisa, please, can you go over your example again?
It's okay. I say I'm using like magnetic field, North Pole and North Pole, South Pole and South Pole. They repel. They are not in the same direction. Why North Pole and South Pole? They contrast. So North Pole and North Pole is just like a negative correlation. Why South Pole and North Pole is just like a positive correlation.
Hold on.
Let me say
Unisa.
something.
Yes, ma.
Hold
Hello,
on.
ma.
Unisa.
Yes, ma.
Hello.
The fact that they are repelling does not mean it's negative. Remember, negative is one person is there, the other person is not there. One person is loving, the other person is not loving. So it's positive and negative at the same time.
Okay, I'm just using the repelling as one is loving, one is not loving. Just like
please,
okay.
can you use a more relatable example?
Okay.
Doctor, please, Peter is here.
Okay.
This one. And you can't close this, please.
Eunice, please be fast. Our time is going fast.
Okay, a different example. Okay, let me think of a different example. Okay, while I'm still thinking, let somebody else carry on.
Okay.
So who has not spoken? Who has not spoken before?
Manasseh has not spoken. Manasseh.
Peter have not spoken.
Juliet have not spoken.
Manasseh
Tokuma, please.
Peter have not spoken.
Manasseh,
let's hear your example.
Okay, good morning, everyone. If we look at the security situation in Benue, if the security institutions were doing their jobs over the years, it wouldn't have worsened to the situation it is now. So if they had been doing their security institution from last year to this year had improved their efforts, there would have been if they had improved their effort, we'll say it's a positive correlation, but the effect of their strategies or structures on ground being so bad, it is a negative correlation. That is
So what are the two variables now in your example?
the variables I would say the security structures, and then the people that are the Benue communities. The people that have been killed in our communities, I would say that's the variables.
Well, this example, can you think of something else? Because are they actually doing anything? If they were improving security and we're still having these clashes, we say it's negative, but is there actually an improvement?
Doctor, please give me a chance to.
Hello, ma'am. Let me also say something.
Hold on now. We're not done with ATSE.
Okay.
Can you think of a more relatable example where you can clearly tell us the two variables?
Okay, let me say something. I think I have one.
ATSE.
I'm sorry. Let him continue.
Okay,
Hello?
Olima.
Doctor, he said.
Okay. Good morning, ma.
Good morning.
Good morning. Is up.
Please, Olima is speaking. Let's listen.
Okay, let me give an example of a negative correlation. Let's take a car. A car, if you're on a speed, the journey is 3 hours. The higher the speed, the lesser the journey becomes. So you discover that there is a negative correlation, because if the speed was supposed to take you, if on a normal day the journey is supposed to take you 3 hours, you take a speed that is higher than above 120. Let's take it that you get to that place earlier than the 3 hours. So it's a negative correlation. That as a car speed, the time it takes to reach a destination drops. Hello?
Please, Doc, give me a chance to throw more light on this.
Okay. Let me also say something.
Okay, Olima. So, but I would think that speed and distance, the higher the speed. Okay, so you're saying the higher the speed, the lesser the distance.
Yes, ma'am. Yes, ma'am.
Let me say something.
So finally, Manasseh, let's hear you.
Thank you very much. I would like to give an example using agriculture.
Beautiful.
Poultry farm, as I know that so many people keep birds. By the time you have your birds and then you give them good feeds, they are feeding very well, the growth will show on them. You see them growing very well. That is a positive correlation. The situation where you are feeding them, the more you feed them, the lesser they are growing. They are not growing, they are looking tattered, they are looking haggard, not even going anywhere, maybe because of the attack by one disease or the other. It becomes a negative correlation.
So I'm giving you a thumbs up. This is a beautiful example. So please, this seals it up, right? Is there anybody that doesn't understand positive and negative correlation now?
Yes, mommy, let me explain.
Hey. Bem, let's hear you.
Okay, good morning, everyone.
Good morning.
Yes. My example on negative correlation is this to Jigba.
Jigba understands now. Why are you directing it to him, to the class?
Yes.
Okay, Jigba, in your family, you have a brother, maybe an elder brother or a younger brother.
Yeah.
You always give him money to do something or to achieve a particular goal. But whenever you need money, he will have money, but he refuses to give to you. He doesn't care whatever you are going through. That's a negative correlation. But in you understand, in the same family, there's another brother. When you give him money, anytime you need money, he gives you money. That's a positive correlation.
Okay, Bem, you have won now. So can we move on? You have gotten 1 mark.
Yes, ma'am.
Yes, ma'am.
All right. So, Mr. Jigba, I'm going to give you 1 mark for your for your questions, because your questions are bringing more clarity to the class, right?
Thank you, man. Thank you.
Yes, I love your interactivity. So you have earned 1, 2 for today. Any other question? Can we move on? So, Unisa and Ase, you're still going to explain well to earn your mark, because the examples you people give, I'm not sure everybody understood positive and negative correlation from your example.
No problem. I thank God someone must explain.
I want to give an example and earn 1 mark.
Hold on. The class is, we still have more to come, please. All right. So, can you see my slide?
Yes, ma'am.
Yes, ma'am.
Okay, so we can see the negative correlation. You see that from 10, the points are going down up to this 20. Can we all see it?
Yes,
It's
ma'am.
exactly opposite the positive. So it's declining while positive is ascending. Negative is declining, positive is what? Ascending. Is that clear?
Yes, ma'am.
So the way I might ask my own question, I might just bring out graphs and ask you to identify the type of correlation or relationship between the variables. I hope everybody will be able to do that.
Yes, ma'am.
Yes, ma'am.
All right, so let's move on. Non-linear. Just like was it Abu that asked the question? Just like the name is, non-linear means it's non-linear. It means non-linear relationship have an apparent pattern. It's just that it is not linear. It can be zigzag, it can be any way it wants to go, but it is not linear. And we know linear means straight. So it means for non-linear relationship, it's not straight. So for example, you have 2 people that are in relationship. Today the love is sweet, tomorrow it will be bitter. But they will say they will not leave each other. The next day they will come again. It will be sweet, oh, it will go bitter. So it's just zigzags. It's not linear. You cannot say it is like this, it is like that, right? So there is a pattern. It's just that it is not what linear. We know there's an association. We know there's a relationship. It's just that it is not what? It is not linear. Are we okay?
Yes.
Yes, ma'am.
Any question?
Yes, ma'am.
So what's the question? Any question, please?
No question, ma'am.
So like you asked Abu, so we say, for example, as age increases, height increases. It will reach a point, whether age is increasing, height is no longer increasing. So normally for a linear pattern, we expect that both will keep going up. Age is going, height is not going. So the moment is not just straight, it is known as non-linear. So an example is what we have on the screen. Can we see what we have on the screen?
Okay.
So as age is going, height is going up to a point, right? You can see that the rest is just constant. So any relationship, regardless of what we have, it might be zigzag. As long as it is not linear, we say it is non-linear. No correlation. Hello?
Hi.
No correlation. When 2 variables have no relationship, there is no straight line. There is even non-linear. They don't jam. Can anybody give an example if you understand no correlation?
When 2 variables have no.
So when one variable changes, it does not even affect the other. Whether you are going south or home. Any example? Who are those that want to end mark? Example of no correlation.
Peter is here.
Who?
Peter Ben.
Atse. So Atse, it's time for you to end your mark now. No correlation. Tokuma, we are waiting for you.
Okay, being a millionaire and finding happiness, there is no correlation there. It doesn't guarantee being happy. There is no
We can
guarantees
argue
there.
this one. Don't give me money, I'll be happy. Oh, how will you say being a millionaire and no happiness? Do we all agree with this example?
No,
no, man.
I say, look for another example. If I have money now, today I'll be happier.
Mom,
So please, I expect you
Doc
to bring
Peter.
examples that are relatable, that, you know, there'll be no
Yeah,
need to debate.
Hello, ma. Hello, ma.
Peter is here. Bem is here.
Gwakia is here.
Asongo, Nathaniel.
Okay, my own example is that, like for the Boko Haram and then the Nigerian army, there has no relationship at all.
Explain.
Okay, like anywhere, the Nigerian army, maybe they go to the forest or to the Sambisa forest, their own target or their aim is just to kill the other ones, which are the Boko Haram. And then the aim of the Boko Haram too is to kill the Nigerian army. So there's no relationship at all between them.
But Nathaniel, each of them are looking for themselves to kill now. That's an association. It's just that it is not in a good light, isn't it?
Yes.
So remember, we say for no correlation, when one variable changes, it does not influence the other variable. Okay, let me give an example.
Example.
Let me give one.
Okay, sorry.
I have
Who has
one
not
too.
spoken?
I'm here. Is it like
Okay,
I have one.
Ifan, let's hear you. Ifan, let's hear you.
Yes.
Black and white have no relationship.
So another example of no correlation is ASU strike and IPES. Whether ASU strike is going on, no, IPES will go on. Whether there's no ASU strike, IPES will go on.
Yes. So let's clap for her. That's a beautiful example. So, for example,
I
if
have one
ASU decides to go on
example.
strike today, our class will still continue. Any
I have
change in
one
ASU does not affect the activities of IPES. So that could be an example of there's no correlation between the activities of
I have
IPES
one example.
and ASU strike.
Another one is black and white.
Okay,
That's
Sesu.
Black
Sesu
and
Sunen.
white.
Sesu Simon. Sesu Simon.
Ma, I'm here.
Okay, let's hear you.
I want to give an example.
Okay.
Bank and money. If there's money in the bank, whether you withdraw your money, the bank is still there.
The bank will do what?
The bank will still be there. Whether your money is in the bank or you withdraw your money, the bank is still there.
So, what kind of relation is that?
No correlation.
Choke, I beg.
Somebody says it.
That one choke, man. Because the bank is there because of the
Simon, that one
custody.
choke.
I have an example. I have an example, ma. That's my
I have one.
All right, let's hear from Busu Kumade.
Okay, man. The another non-correlation is your IQ and your size of head.
Okay. Explain to us.
The low IQ or high IQ, the size of head is still the same.
You said what?
I mean your IQ and size of head. If a high IQ doesn't mean your size of your head is going to be big. It's still the same.
Okay, I'm going to give you one mark. But when I was small, they used to insult children. They'll say you have big heads. The children will say, at least I know something, no? But yes, I understand what you're trying to say. Okay, the last person, we need to move on.
I'm here.
Let me give you an
Who is that?
example. Desmond, he's here.
Okay, let's hear from you, Desmond.
My example is about when a man get married to two wives. And the two wives have no correlation when they are living under one roof.
Explain.
Yes. In decision making about the other wife's children, the other wife's welfare, the other one prefers that his welfare should be more than the other one in the family.
So those two wives, they don't have anything in common. They don't eat food in common. Their children don't play, or is that what you're trying to say?
The two wives, they never have any relationship when they are living under one roof. It's always as like everyone has his own separate thing. in extended family.
Okay. Okay. I'll give you 1 mark. Okay.
Bam's hand is up.
Abba, Bem is the only you in the class.
Jigba want to give an example.
Okay, let's hear
relationship
Jigba.
between
Let's hear the mighty Jigba.
I have an example to give, ma.
Let's hear Jigba.
My example is an example of no correlation is prices of items in the market. It doesn't matter whether your salary. When the price of an item is fixed in the market, whether your money is not up to that, but the price of that item is tagged to be like that. Whether your income is low or not, it doesn't bother the seller or the price of the item. I think it doesn't have any correlation.
Okay.
Or does it have, ma?
Yes. Okay. As an economist, okay, it's relatable. Let me just take that. So when they don't even consider your income.
Prices of items is up. There's no correlation.
Okay, I had given Jigba 1 mark earlier on.
Bam hand is up.
Bem, even if you answer 10 questions, you have gotten 1, you have gotten 1. No. So let others answer.
Additional 1 mark, ma.
All right. Okay, so let's move on. I believe everybody in the class is clear about positive, negative, non-linear, and then no correlation, right?
Yes, ma'am.
The example I wanted to give. So, for example, for those of us who are Christians, we know in the Bible they say 1 man, 1 wife. If a man is married, the correlation should only be between him and his wife. He's supposed to have 0 correlation with chicks. Do we understand? But when you have side chick, it's no longer 0 correlation. The norm is that there should be no correlation between you and another woman, isn't it?
Yes,
men are not answering me.
The men will not answer again.
You don't like this example I'm giving?
No, we are with you, ma. We are with you, ma.
I said that should be the norm, even though we know sometimes it's not the norm, right?
That one choke.
David, what do you want to say, Ralph? Is there anything you want to say?
I also want to give an example, ma.
Okay, this is the last example we're taking on this. All right, let's hear you.
Okay, my example would be that, for instance, as you are growing, you are now a doc to heading to associate prof to prof. As you are growing, even your husband is still Mr. His status as your husband will not change.
Yeah, it looks to me like you're explaining constants. So what are you saying about this relationship now? You're saying it's 0.
I don't quite agree with him.
I think it's the
I don't
title
quite
he's
agree
talking
with him.
about. Your title and that of the man.
Okay, my
So if he
title.
doesn't do what you're
Monica.
yes, ma. Your academic title, yes.
Okay,
as
so my
doctor,
academic title has 0 relationship with my marital status. Is that what you're saying?
No, I'm not saying as in what he means. He's trying to say that if your husband doesn't maybe go do MSC, PhD, he will bear Mr. while you will be a doctor, associate professor. That's what I understand from what he said.
Dina, I also do not understand, but I'm trying to make myself believe that he's saying that regardless of how far I grow or my title, my career, it should have 0 correlation or relationship with my marriage, right? That means even if I go far, it shouldn't influence.
Interfere.
Is that what you're trying to say? It shouldn't interfere. Is that what you're trying to say?
I think
Ralph.
that's what he's trying to say.
Maybe that's what he's trying to say. It shouldn't influence your.
But he's not speaking for himself. We are the ones only inferring.
From my understanding, I think he's saying your level of thinking or IQ will no longer be the same.
Let's
You
move
see,
on.
we all have different variants of what we think he's saying. Ralph,
Yes,
can you speak for yourself?
He himself have run away.
All right, okay, so let's move on. So
Can I
this
give
is
an
an example. Hello. Hello, can we move on?
Okay, ma. All right.
Please, there will be more room for examples. Don't worry. So, For a negative, for zero correlation, the points are scattered. You cannot even connect them. You know, for non-linear, we say it might take a zigzag pattern or something, but this one, you will go like this, go like this. It is not even, it doesn't have any pattern. At least non-linear, there's a pattern. It's just that it's not straight. But for zero correlation, there is no pattern. So now, we're going on to say that because visual examinations are largely subjective, we need a more, so when we say subjective, everybody can come up with their own opinion, right? So we need a more precise and objective measure to define correlation between two variables. To quantify the strength and direction of the relationship between two variables, we use the linear correlation coefficient. So all what we've been saying, we've been using visuals, right? So let us really check so that we'll have a value to tell us whether there's actually correlation or not. And now, so what are the types of correlation coefficients we have? We have the Pearson's correlation coefficient. It measures relationship between, it measures linear relationship, and the data has to be continuous. When I say continuous, what do I mean? Anybody?
That's 3.2.
Decimal.
It's not a whole number.
Right. So for linear correlation, the word should be when the data is quantitative, whether it is point or whole number, it has to be numbers. You use Pearson correlation coefficient when your data is quantitative. Are we following?
Yes, ma'am.
So whether there's point or not, the idea, I'm going to change it, is that the data has to be quantitative. It has to be measured numerically. And then this is the formula for Pearson's correlation coefficient, where R, your correlation coefficient, is a summation of X minus your mean. Remember I said that mean is X bar, then multiplied by Y minus mean of Y, divided by the square root of the summation of X minus X mean squared times the summation of Y minus Y mean all squared.
Please excuse me, ma'am.
Okay.
Sorry. Please, we've been talking about correlation, and now we are talking about correlation coefficient. Is it the same thing, or we're having another terminology? Thank you.
We are saying, you know, we've been using graphs to determine whether it's positive or negative. Are you following?
Yes, ma'am.
So we are now saying that a graph now can be subjective. People can argue. Let us look for something more solid to use to determine the correlation between two variables and we say that could be the correlation coefficient because it will give us a number. If, for example, I say just like zero correlation, if we just use only graph, somebody can say him is seeing pattern, me I can say I'm not seeing pattern. So we are saying let us look for something that will not be subjective. It will be something that when everybody see, they can agree to whether there's correlation or not. So we're going further to look for a measure that is stronger than visuals. Are you following?
Okay, ma'am. So it means under correlation coefficients, there's no graph. Why correlation
coefficient? You will just calculate and get a number. It's the number that will tell you whether there's correlation or not.
All right, ma'am. All right, thank you.
Is this clear?
Yes, ma'am.
So the Pearson correlation coefficient is used for quantitative data, while the Spearman is used for ranked data or relationship. So when we say something is rank, there's order. Are we following? So for just numbers, most of the work we'll be doing will be using Pearson. But when you have data that is ranked, you can now use Spearman. So let's go further now. To explain your question properly, anywhere you see R when it has to do with correlation, R represents correlation coefficients. Are we following? And the range of correlation coefficient, when you calculate that R, it will range from -1 to +1. You cannot have correlation coefficient that is 2 or 1.2 or 3. Anything that is beyond -1 or +1, it is not correlation coefficient you have calculated. Are we following? So if I give you numbers or data and I ask you to calculate the correlation coefficient, the moment your answer is more than 1, just know that there's error. Go back quickly, because correlation coefficient ranges from -1 to +1. I can see some hands up. Any question? I can see Gemga and Precious. Is there any challenge?
Yes, ma'am.
What's the challenge?
Sorry, ma'am. Like me, I'm not mathematical oriented. Please, ma, if this stage you enter now, I have to take it slowly for you to carry some of what's around. Please, ma, if I offend somebody, because from my day one, I don't like marks. When I saw this course, I said, wow, it don't happen. Please, ma.
I don't like math. You don't know math.
Okay, so because it's a virtual class, and even my graphic board cannot accommodate what it looks like, I will advise maybe a week to exam if we can come physically, where we have boards, where we can ask questions, where it's going to be face to face for us to do revision, right?
Yes, ma'am.
I don't know. Well, the class can determine if they want to, but you need to tell me ahead so that I can plan that into my schedule. But Mr. Gemga, at this point, you have to like calculation. That's why when I say come to the class now, so I'll give, as we go on, you will see example. I'll break it down for you to see. But so this is one of the disadvantage of a virtual class, right? There are some things that no matter how you want to do it, there's no how. When I'm seeing your face, I'm understanding. I can't see your faces to understand your level of comprehension.
Assimilation.
Or assimilation. But at this point, I'll advise, especially for this course, let us create time for revision. You know that exam is physical. So if we can come maybe a week to exam and then trash out boarding questions on people's mind, it will be great. But if not, you can locate your classmates who you believe they understand and then work things
I
out.
don't believe
Hello, ma. We're having physical revision class.
We're having physical revision class, right?
Yes, ma'am.
Beautiful. So at that point, if you practice and practice, at that point you don't understand, we'll dig it out together. Is that okay?
Okay, ma.
Yes,
but let's go on. You will see the way we have broken the calculation. I don't think it's something that is too big because it's still basic statistics we're doing. So are we clear? Can we move on?
Yes, ma'am.
So now what we are looking at is the properties of correlation coefficients. And the first one is that it ranges from -1 to +1. Are we clear with that?
Yes, ma'am.
So if I give you X and Y and I ask you to find the correlation between X and Y, and your answer is -2, it is wrong. You don't even need to submit for you to know it is wrong. Your answer is 1 point something, it is wrong. It ranges from -1 to +1. So it can be 1, it can be -1, it can be 0.9, it can be 0.8, it can even be 0. Who can tell me what does 0 mean?
No correlation.
Who said no correlation?
Jennifer.
Jennifer. Is it Jennifer Jato?
Jennifer Chekwa.
Okay, so let me give you 1 mark. So this is where I'll ask questions now for people to earn mark. So I said that so if you calculate correlation and it is 0, it means it is what? No correlation. I want to ask, let me be seeing everybody before I ask. If you calculate your correlation and your answer is +1, what does it mean? Raise up your hand. Raise up your hand. So I don't want chorus answer. Please raise up your hand so that you can earn marks.
Mine is up, ma.
Mine is
up. So Unisa, what does it mean?
Positive correlation. Positive correlation.
Beautiful. So you have earned your 1 mark. What if we calculate correlation and it is -0.4?
Still me.
No, it cannot be you now.
My hand is up.
Jemima, say we say.
Negative.
Jemima.
Yes, ma'am.
Beautiful. So when you have negative, so it's easy. If you have negative, it's negative correlation. If you have positive, it's positive correlation. So let me get your full name. Jennifer who?
Jennifer Chekwa.
Jennifer
Excuse me,
Chekwa.
ma. But excuse me.
Yes.
If I should hear your question, you say -4. Is it -4 you said?
Minus 0.4.
Okay.
Is this clear?
Yes, ma'am.
Yes, ma'am.
Any question? So
None for
the first characteristics of correlation coefficient is that one, it ranges from -1 to +1. The second one is the direction. It can either be positive or negative. So if you have 1, it's positive. If you have -0 is negative. It's as clear as it needs to be. Then the third property is magnitude. The closer it is to +1, the stronger the relationship. So a correlation of 0.9 tells us that it is positive and very strong. Are we following?
Yes, ma'am.
Okay.
Yes, ma'am.
A correlation of 0.2 tells us it is positive but weak. Are we following?
Yes, ma'am.
Yes.
So the closer your correlation is to plus or -1, the stronger it is. A correlation of -1 tells us it is strong but negative. Are we following? A correlation of -0.2 tells us it is negative and weak. So the minus and plus just tells you whether it is negative
Again, ma'am,
or
come
positive.
again.
I said the minus or plus tells us whether it is negative or positive. The closer it is to 1, whether negative or positive, the stronger that relationship is. Is this clear?
Yes, ma'am.
So I've mentioned 3 properties of correlation coefficients. Number 1, the answer always ranges from -1 to +1. That's its range. 2, correlation can either be positive or negative. 3, magnitude. The closer correlation is to plus or -1, the stronger the relationship between the two variables. Number 4, symmetry. The correlation of x and y is the same thing as the correlation of y and x. So any variable that comes first does not affect the correlation coefficient. If you say age and height, is the same thing you get if you say height and age. Are we following?
Yes, ma'am.
So the correlation of x and y is the same thing as the correlation of y and x. Who is unmuting now? Who is unmuting? Please, can we all mute our microphones except we want to speak? Are we following?
Yes, ma'am.
Is there any question on symmetry?
Think you should come again, ma'am, regarding symmetry.
So I say, for example, if you want to find the correlation between somebody's age and weight, you know they are all quantitative variables. Age is number, weight is number, right? Remember, Pearson is used for quantitative variables. Now, if you say age is X and weight is Y, and you find the correlation coefficient, it is the same thing you will get when you say weight is X and age is Y. So the correlation of X with Y is the same as the correlation of Y with X, regardless of which one comes first. There's nothing like, we don't give position. Whether you put age first or weight second, it will still give you the same answer.
Okay.
Is this points on symmetry clear?
Okay, yes.
Only one person is answering. Jemima, your hand is up. Is there any challenge?
Yeah. That is Doc.
Yes.
If I may understand the symmetry correlation, that is, it's just like a nominal scale, which does not have a category. It is anyhow. It is not ordered. Anyone can come first and anyone can come last.
Beautiful. That is how it is with correlation. If you like, you come first. So if I like, me come first. So correlation coefficient will still be the same. So they are symmetry. So we have listed 4 characteristics. And I'm telling you ahead, I'm going to ask you to give me 5 characteristics of correlation coefficient, Pearson's correlation coefficient. Number one is the range. It is from -1 to +1. Number two, correlation can either be positive or negative. Number three, the magnitude. The closer it is to plus or -1, the stronger the relationship. Number four, symmetry. Correlation of X with Y is the same thing as correlation of Y with X. Do we understand these 4 points?
Yes, ma'am.
The last one is that correlation does not have units. If you find correlation, if I ask you, find the correlation between medical doctor salary and lecturer salary, and at the end of the day, you go and put Naira, you have failed, you will not get the points there. Correlation is unitless. Are we following?
Yes, ma'am.
When I say it's unitless, let me drive for this example. If you find the correlation between two people's weight in kg, it will still be the same thing if you find their correlation in pounds. Are we following? This class is silent. Or have I lost them?
We are following, ma'am.
No, I don't
So
understand.
the idea is that correlation coefficient does not have a unit. Don't go and find correlation coefficient and put Naira or kg or something at the end. You will lose some mark because it is unitless. So whether you measure correlation coefficients, you are checking in weight, in kg, in pounds, or any unit. At the end of the day, it is what? Unitless. Is that okay?
Yes, ma'am.
Understood, ma'am.
See, if you go back to this formula, you can see that what is up is divided by what is down. So the unit up will always cancel the unit down. Is that okay? Is that okay?
Okay.
All right. So now this is a guide to interpreting correlation coefficients. Any correlation from, zero means no correlation. I hope we know.
Yes, ma'am.
So this will be 0.1, not exactly 0. 0 means no correlation. Is that clear? Don't worry. What are the two things I have said I will correct now before I give you the slide? This one is 0.1 to 0.3 because 0 is not weak. 0 means no correlation. Is that clear?
Yes.
Don't you come and go and get 0 and say there's weak correlation. 0 means there is no correlation. So from 0.1 to either plus 0.3 or minus 0.3.
Weak.
Is there any challenge? Some people are talking. Is there any challenge? Can I move on?
Yes.
Yes.
So when you calculate your correlation coefficient and it's maybe 0.2, 0.3, 0.1, we say that it is what? Weak. If it's minus 0.1, minus 0.2, minus 0.3, we say that it is what? Weak. Are we following?
Yes.
Now, from 0. This should be 0.4 safe, not 3. I'm going to change these boundaries. From 0.4 to 0.7 is moderate. So this should be 0.69. From 0.7 to 1 is strong. Is that okay? If it is perfect 1 or perfect -1, we say it is perfect correlation. So if you calculate correlation coefficient and it gives you perfect, it gives you 1, that means there's perfect correlation, right? That husband and wife, they are inseparable. They give birth to them at the same time. They will die at the same time. Perfect correlation, no cheating. Is that clear?
Yes.
Is there anybody that doesn't understand?
Ma, please, the strong correlation is it plus 0.7 to plus or minus 0.
Yes, that's why you see plus or
0
minus, whether
or
it's
1.
minus 0.7 or 0.7, it is strong. It's just that one is strong positively, the other one is strong negatively.
Okay, ma. So when it's plus 1.0 is strong since it has a number which is 1 before the
When
0.
it's 1.0, it's not strong, it's perfect.
Okay. Okay.
Is that clear? Don't say
Yes,
one is strong, one is not strong, one is perfect. Perfect is above strong. Are you following?
Yes.
Okay,
Any
hello,
other
ma.
question? Yes.
Okay,
Yes.
so maybe you will change that strong to maybe 0.9 so that
Okay, I understand what you're saying. Yes, 0.99.
yes,
I don't
yes,
want,
ma'am.
let me even change this while we're talking. Any other question? Let me quickly change
Yes,
it.
ma.
Okay.
You have taken what I wanted to point out to, but then I'm seeing where the interval where we are having 0.1 to 0.3. It is 0 to 0.3. Then which says is a weak correlation, and then 0.3 again to another. I think 0.7.
I'm working on all those intervals.
Okay.
So don't worry, I'm going to upload now for you to see.
Okay.
Any other question? Any other question?
No question.
No question, ma'am.
The question that is there is just go over it for the last time.
So who wants to help us go over it? Who wants to help us go over it quickly?
Can I try?
Who wants to try?
Icheme Jonathan.
Are you guys still seeing my screen?
No.
No,
Okay,
ma'am.
so
It's not coming up.
all right, Icheme, you can try.
It's okay. We when we say 0 to plus or minus 0.3 correlation, it is weak. And then you say the plus or minus 0.4 to 0.7 is moderate. We talked about plus or minus 0.8 to 0.9 is strong correlation. But when it is plus or minus 1, it means the relationship is perfect. And then you set example of, that means the husband and the wife, they born them the same time, grow up in a similar way, and possibly they will die at the same time. I think that was the kind of example you gave just now. Thank you.
Mr. Jigba, is that okay? Mr. Jigba, is that okay? Hello?
Aye.
Who asked the question? Is that okay? Eh?
It's like network has thrown Jigba out of the class.
Okay.
I'm back now.
Okay. Did you understand what I just said, or you heard me?
No, in fact, network showed me aware.
It's okay. Let me repeat quickly for you to hear. She's saying that a relationship exists when the relationship is from 0 to plus or minus 0.3. It means it's a weak relationship. It's a weak correlation. Then when it is plus or minus 0.42 plus or minus 0.8, it means the correlation is moderate. But when it is from plus or minus 0.7 to plus or minus 0.9, it means it is strong. But when it is plus or minus 1.0, that means it is perfect correlation. That shows that she gave an example by that probably the husband and wife born them the same day and they get married to each other, and possibly they may die at the same day too. That was the example she gave. Thank you.
All right, so when you find correlation and you get a figure, it is not enough for you to just stop at, okay, I found correlation, it was 0.7. You must explain your results. It means that the relationship between this and this is positive and strong, or is negative and weak. Don't just find a figure and then you end there. Is that okay?
Yes.
All right. So if you look at my graph, you get an example of. Hello.
Excuse me, ma. Can you please increase the screen?
Okay. Can you see it now? Is it better now?
It's better now.
Okay, so we can see strong and positive, just like I explained earlier on. We can see moderately positive. We can see weak positive. So these are examples. So when you get a figure, tell us what that figure means. Don't just end at calculating it and then you stop there. Is that okay?
Yes.
All right, so let's move on. Oh, sorry. So let's look at this example. Suppose we have data for the number of hours studied by 5 students and their corresponding test scores. We want to determine if there is a correlation between hours studied and test scores. Do we understand what we want to do?
No.
We want to check if there's a relationship between the number of hours students spend studying and the scores they get at the end of their tests. Do you understand the simple thing we want to do here? Okay,
Yes.
So now, if, for example, your objective in your thesis is that you want to check if there's a relationship between farmers and herdsmen, which method will you use? Correlation. Anytime that you just want to check, is there a relationship, is there an association between this and this? The simple tool for you to use is what? Correlation. So in our case, we want to check, is there a relationship between the hours people spend reading and their test scores? Simple correlation. Because hours spent reading is numeric. Test scores is what? Numeric. Are we following?
Yes.
Hello.
We are following, ma'am.
Okay. Hours spent is numeric, and time is what?
Time is also numeric.
We couldn't flow, so you take it again.
It's not time. Hours is the same as time. The other one is test scores. The scores.
Okay, test score, yes.
Yes.
How do you measure time? Is it not in numbers? How do you
It's in
measure
numbers,
test scores? Is it not in numbers? So because
It's
the
in
both of
numbers.
them are numbers, we can now go on with our Pearson's correlation coefficient.
Okay.
Is that okay?
Yes, ma'am.
So for the first student studied 2 hours, got score of 50. The second one, 3 hours, score of 60. The third one, 5 hours, score of 75. The fourth one, 7 hours, score of 85. The fifth one, 9 hours, score of 95. Before we calculate this correlation coefficient, I have 2 marks for the person that will answer this question. But if you have answered before, it's 1 mark. Can we see my screen?
Yes, ma'am.
Yes.
By men looking at my screen, can you tell me the kind of relationship between hours studied and test score? Let me see your hand, though. Don't answer anyhow. Let me see your hand if you know it. Check what, Jennifer.
That's a linear correlation, ma'am.
When you say linear, that's not what I want to hear. Under linear, there are 2 types. So I want to hear the types under that linear.
That's a positive correlation.
Who just talked?
It's Ben.
Ben, you are correct, but I didn't ask you to speak. So I'm just going to clap for you, correct. So we can see this is a positive correlation. As the number of hours are increasing, we can also see that test scores are also what? Increasing. So this is a perfect example of a positive. We don't know whether it's strong or not, but by men looking at what we have on our screen, we know that it's going to be what? Positive. Is this clear?
Yes, ma'am.
Yes, ma'am.
Is there anybody that doesn't understand why it's positive?
Okay. At least people can understand.
Understands, we can go on.
Can we move on?
Yes,
Let's move. Since Jim understand, we can move.
Please.
Why would you say?
Throw a light.
Oh my goodness.
More
All right. So this is how it is calculated. So Remember that. So we said let our studied be X, let test score be Y. When I talked about symmetry, even if our studied is Y and test score is X, it will still give us the same answer. That's what I meant by symmetry. Are we following?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. So this is the formula. X now. You see this X. Let's go back. We say X is our studied and Y is test score, isn't it? So X is our studied, Y is test score. This X mean is the mean of X. Let's go back quickly. Who can tell me what the mean of X is? The first person to get it, 1 mark. What is the mean of X? Let me calculate mine too.
Yes, something studied.
Yes, and Gemga, what is the mean of X?
Our studies.
No, I say mean.
Oh.
Who has found the mean of X?
7.
No. Please raise your hand when you want to talk so I can give you the correct, I can assign the right person the right mark.
I've gotten the mean.
Who can tell me the mean of
The mean
X?
is 5.
My the mean 4.2.
The mean is what?
5.
No.
The mean is 1.1.
No. Hey. Mean we did yesterday.
That's the question.
The mean is 6.
That's the question.
Who said 5.2? Who said 5.2?
5.2.
Who said it?
Fire.
Who said 5.2?
Jennifer said it.
It was a male that said it first. A male. I don't know.
Emil said it first before me, Sha.
This is why I say raise up your hand before you talk. So to get mean of X, you just say 2 plus 3 plus 5 plus 7 plus 9. You get 26. How many students do we have? 5. 26 divided by 5, 5.2. That is the mean of X. To get the mean of Y, you do the same thing. 50 plus 60 plus 75 plus 85 plus 95 divided by 5. Is that okay?
It's okay, ma'am.
Yes, ma'am.
All right. So you can see that the mean of X is 5.2. The mean of Y is what? 73. Can we all calculate mean?
Yes, ma'am.
Is there anybody that cannot calculate mean? Is there anybody that cannot calculate mean?
Me.
Who?
But no while because my network was having, I don't log in.
See the way to calculate mean on my screen now. For X mean, you add up all the X divided by 5. For Y mean, you add up all the Y divided by 5. So it's on the screen. Can we move on?
Yes.
Yes, we can.
All right. So the moment you have X mean and Y mean, you can now go. So our X, you bring the value here. You can see our X. Our Y, we can see our Y. Here now we have X minus X mean. What do we mean? You will say 2 minus 5.2. 2 minus 5.2 will give you minus 3.2. Are we following? 3 minus 5.2 to give you minus 2.2. 5 minus 5.2 to give you minus 0.2. 7 minus 5.2 will be positive 1.8. 9 minus 5.2 will be what? Positive 3.8. We'll do the same thing for Y.
Come again. No.
We are lost too.
Hello, not clear there.
Can we see my screen?
Yes.
Yes.
Right.
First, put this one in your head. Mean of X is
5.2.
Last week. No, this week.
Please, who is talking?
Now I think to understand one.
Please, who is talking now? You are making the class rowdy. Can we all mute?
Nathaniel Asombo, you are the host. Please mute everybody.
Yeah, I just did that now, sir.
Okay. So we have gotten mean of X as 5.2, mean of Y as 73. We'll come here. If you like, don't even put the students, put your X. I'm going to give you X to calculate. So your X is 2, 3, 5, 7, 9. You're not forming X. I'm going to give you X and Y. Then I ask you to find the correlation coefficient. So this first 3 column will be given to you. It is the other ones that you're going to fill. Now, to get the third one, X minus X minus the mean of X, we got the mean of X as 5.2. So the mean for this the X minus X mean for this first student will be this X now. 2 minus that 5.2 we got. Because 5.2 is greater than 2, it will be minus 3.2. Is that clear?
Yes, sir.
We are not clear. I'm lost.
I'm
lost.
Hello, ma. Let your cursor be moving so that we follow you, ma.
I'm lost.
Can you see my cursor now?
Yes, ma.
Or maybe you just
So-
increase the size of the screen. Okay.
No, I can't increase it more than what I have here. For this first student, we said the mean of X is what? 5.2. Is that not what we got?
That's what we got.
So I'm going to give you students, I'm going to give you X, and I'm going to give you Y. The remaining ones here, you are the one that will find it. Is that okay?
Okay, ma'am.
Now, for you to find this X minus X X mean, you will do the X mean is 5.2. So 2 minus that 5.2 we got, it will give you minus 3.2.
Okay. That's good.
3 minus that 5.2 will give you minus 2.2. 5 minus that 5.2 will give you minus 0.2. Now, because 7 is greater than that 5.2, 7 minus that 5.2 is positive 1.8. 9 minus that 5.2 is positive 3.8. Is there anybody that does not understand how we are getting this one?
No, it's clear here. It's clear at this stage. See, the cursor none is working.
Okay, thank you. Can I move on?
Yes, move on.
Ma'am.
Excuse me. To get Y minus Y mean, we got the mean of Y as 73. So 50 minus 73 minus 23. 60 minus 73 minus 13. 75 minus 73, 2. 85 minus 73, 12. 95 minus 73, 22. This is how we got this one. Is there anybody that doesn't understand?
Okay.
Only one person is doing okay. Oh. Some people
Yes,
don't just
I'm
like seeing maths.
Ma, we are muted.
We understand
We are
now.
following.
Understand
Say
how we get
okay.
X minus
What?
X mean and Y
What is the
minus
challenge?
Y mean.
There is no challenge.
Now, this place, X minus X mean squared. To get this one, you will come here to this X minus X mean. Minus 3.2 times minus 3.2. So you will square all the numbers here. That's what we have here. So minus 3.2, you know that minus multiplied by minus becomes positive. So under this X minus X mean bar squared, everything has to be positive. Because whether it is negative or positive, the moment you square a number, it becomes positive.
Negative or negative.
Negative times negative is positive. Is this clear?
Yes,
ma'am. Please
but
come
I
in.
believe
Yes,
that
ma'am.
is the calculator that will be doing those works.
Is what?
Is the calculator that will be doing those
Yes,
works.
at your level, you're allowed to use calculator. Yes, it's fine.
Hello, ma.
Yes.
Please, how do we get the X minus X bar square?
This one here, are you seeing my cursor?
Yes, ma'am.
Everything we have here is what you have here squared. So use your calculator. Minus 3.2 times minus 3.2, it will give you 10.24. Minus 2.22 times minus 2.22, it will give you 4.84. Minus 0.2 times minus 0.2 will give you 0.04. 1.8 times 1.8 will give you 3.24. 3.8 times 3.8 will give you 14.44. Is that clear?
Okay. That's fine.
Is there anybody that does not understand? I wish I could finish this class today.
It's very clear. I just wanted to tell them that they should just follow the formula bar at the top to make it easier for you. Because with the formula bar, I think it's self-explanatory.
So it's the same thing for y minus y by square. If you do minus 23 times minus 23, you get 529. Minus 13 times minus 13, 169. This one is saying any number you have here, square it. And square means multiply that thing by itself. Is that not what square means in maths?
Yes.
So square, when you see square, it means multiply anything you see there by that thing. If it is beauty square, beauty times beauty. If it is ugly square, ugly times ugly. That's what square means. Are we following? So the square of anything is that thing multiplied by itself. That's how we got this one and this one. We squared this to get this. We squared this. Sorry, let me use my cursor. We squared this to get this. We squared this to get this. Are we following?
Yes. I got it.
Then for this one, x minus x mean multiplied by y minus y mean is just this times this. It will give you this. This times this. It will give you this. This times this. It will give. So just look at the formula. It's clear. The moment you have these two, every other thing you have there is from these two. So this one is this times this. Look at the formula now. It says x minus x mean. That means what you have here multiplied by y minus y mean. So use this, multiply by this, and get this.
Okay, ma. It's clear.
Is that clear?
Yes, ma'am.
Then, so there's supposed to be one column at the one row at the end here. That row should be summation. So you add everything you have here, add. So you total them to get the summation. So when you come here, you can see that the summation of x minus x mean squared. See, 10.24 plus this, plus this, plus this, plus this gives you 32.4. Summation means add everything there. So because summation of this means this, we added it and got 32.8. Summation of this, we add everything there and get it. So the easiest way to do it is even to create a sixth column where it's total, a sixth row that is total. Add up what you have here. So you create another row here. Everything here, add it. 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 Then you now come and impute them in the formula. So we have just found the summation of those last three columns there. And then you impute them into the formula. Now, who can explain this answer we have? What type of correlation do we have between the hours that you read and test score? Who wants to explain? Raise your hand. I don't want cross answer. Yes, Jennifer, I saw your hand first.
Okay, that's a strong positive correlation.
So I'm going to give you Jennifer who now?
Chekwa.
Is it Chekwa or Jato?
Chekwa.
Chekwa has gotten 4 marks in my class. Therefore, I'm not giving you any marks again. All right, so this is how you, so when you do correlation, you must come up with a figure at the end. When you come up with it, you tell us whether it is positive and strong, positive and average, positive and weak, or negative and what have you. If at the end we do all of this and we get 0, that means there's no correlation between the hours you spend reading and your test score. It is just a coincidence that people pass or fail. There's nothing like that. Is that clear?
Yes, ma'am.
Yes, ma'am.
So let's move on. We have spent a lot of time on correlation. Where is my okay. So the interpretation, the 0.99 indicates a very strong positive correlation, just like we said, between hours studied and test score. This suggests that in this sample, students who study more hours tend to score higher on their tests. So you cannot use this correlation to advise students. See, research has shown that if you study high, you get high scores. So we want to advise you to be diligent with your studies, because there is no way you will study long and not get high scores. So this is how you use the output of your research to advise or formulate policies or what have you. So from this one now, people can boldly tell students that if you read hard, you read long, you're going to improve on your grades. Your scores are going to be higher. Is this clear?
Yes.
It's,
Hello.
it's clear, ma'am.
Very clear, ma'am.
Okay, ma'am. But before that, ma'am, please, can I request for something?
Okay.
Okay, so usually sometimes we have issues with setting the in the past what have been stated for us that we can only do the calculation.
I can't hear you well, Fire.
Okay, ma. So I'm asking if the formula will be stated for us during exams.
Fanya, where in this world is that done?
Done.
It is not done anywhere in this world. Nobody is going to give you the formula. The formula is part of the answer now. If I've given you formula, I've given you answer.
Ma, I have a question, please.
Yes, let's hear you.
Sorry, network threw me out. I don't know. Can you just go back a bit? Let me know how we arrive at this 0.99.
My brother, I am traveling today. We have just 1 hour left. If I keep going back, we are not going to finish what we are supposed to do today. So I want to plead with you to just go over the slides. Right? I'm going to send the slides. So I'm going to be a bit faster. We have about 70-something slides and we're just on 30 and we have 1 hour to go. I've already booked. So it's not like I can increase the time. So I'm sorry about that. But doing revision, if you still do not understand, you can bring it up. You said?
There will be no class tomorrow morning.
So the next lecturer is going to take over because I have something else to do. Except we can have a class from 7 to 8 a.m. From 8 a.m. I'm going to be busy tomorrow. So that if we do not finish my parts, we can now, or if there are questions, we can now trash those questions there. Or else somebody else is going to be handling the class from tomorrow. But I'll be available by God's grace during revision if there are things you don't understand.
Okay.
Is that okay? Now, remember at the beginning, I said it is possible for us to have association and it is not significant. In statistics or research, once something is not significant, we don't give it too much attention. Just like the name is not significant. It is not important. Are we following? Now, this result shows that there is strong, but we don't know whether it is significant or it is not significant. So we need to test further to know whether it is significant or not. Is that okay? Are we following?
Yes, ma'am.
So the test of, I'm not going to bother you with this test of significance because when we come to the lab, you will even see the syntax as we go further. Usually when you check for correlation, all you need to do is just put comma sig so that your output tells you, it will give you whether it's significant or not, and it will give you the level of significance, right? So test for hypothesis, the null hypothesis is there's no correlation between the variables. There's no significant correlation, while the alternative hypothesis is that there's a significant correlation. So we use a p-value to determine if the correlation is statistically significant or not, and common levels are 0.05 or 0.01. We even accept 10% in social statistics, but in medicine, anything beyond 0.05, they will not accept, right? So let's go further. Now, if, for example, we're doing theta, when we put in X and Y, when we import our data, there's our data X and Y is already in theta. This is what we will write to find somebody is talking and then they'll take me back. You will just write, so this is starter output for the example above. So those 5 things I've given, how many people have starter installed on their system? If you put those variables on Excel sheet, save it with any name, and you import it to Stata, all you need to do is to just write in your command window, you write PWCORRXY. You see this comma.sig. If we don't put comma.syg, it will just give us only the correlation. People are talking. I won't go back. This is very sensitive and people are talking.
Please continue, ma. Continue with
If you put significance, so this comma SIG tells data that beyond the correlation, tell me whether it is significant or not. But if you don't put SIG to just give you the correlation, it will not tell you whether it is significant or not. So this is how starter output brings its results. Now it's telling you that the correlation between X and X is perfect 1. Are we seeing this one here?
Yes, ma'am.
We see this one.
Yes, ma'am.
Yes,
ma'am.
So we are asking that the relationship between you and yourself, what will it be? It will be a perfect one, isn't it?
It is.
That's why the correlation between X and X is the same thing, is perfect one. The correlation between Y and Y is perfect one. Now, that one we calculated, this is the answer here. The correlation between Y, oh my goodness. The correlation between Y and X, you can see that it is 0.99. And it goes further to tell us that it is significant at the 1% level of significance. So you can see this one underneath now is the significance. It's telling us that in as much as this is strong and positive, it's not only strong and positive, it's significant at 1% level. As in the relationship is there, gim. Are we following? I'm beginning to lose the class. So correlation is becoming weak.
Yes.
Well,
correlation
correlation between the teaching and understanding is becoming weak, right?
Now,
the sun is
It's strong, strong.
Becoming weak
this
at
one,
this
this one
You
is
said?
entering, no?
It's becoming weak
enter.
at this stage, oh.
my brain.
You said what?
Let's continue. Let's continue.
No audio, ma. Your
No
voice.
audio, no audio.
Unmute her. That means you unmute
Sorry.
her.
Okay, please, let's take, do we understand at this level?
Yes, ma. At the level of
Not
starter,
quite,
we
not
understood.
quite.
Let me tell you where you are having problem. You are not having problem with the correlation. You're having problem with interpreting the level of significance, isn't it? This is where you're having problem, isn't it? Oh, yeah, take your biro. All of you take your biros and write what I want to say. Take your biros and write what I want to say.
We're taking, ma.
Any p-value that is from 0.00, are you writing?
P-value.
Yes, ma.
That is from
Any p-value that is 0.00. So when we say anything that is zero, the moment you have two zeros in front of that thing, that's why I say 0.00. Even if you have numbers, see, as long as you have two zeros after this point, it's significant at 1% level.
Any value that is 0.0 is significant to...
I didn't say 0.0. Or let me put it this way. Wait, let me make it easier this way. I think people understand this way. Any p-value you get, are you hearing me?
Yes, ma.
Yes.
Multiply it by 100 for you to know the level of significance. Is this better now? So multiply 0.001 by 100. What will you get? Is the class still following me at all?
We are following you. Say 0.
0.001 multiplied by 100. What did you get?
0.0001.
I say multiply by 100.
Okay, multiply.
We have 0.1.
0.1.
0.1.
0.1.
Is 0.001 times 100. 0.1. That's what I got.
0.1, isn't it?
Yes.
Isn't it?
Yes, ma'am.
It is.
Any p-value you get that you multiply, that's the answer is from 1 to 0. It is significant at 1%. Are you writing it down at all? This is the easiest way I can explain it to you. And this is the easiest way you can understand it. So if you are confused to know whether something is significant or not, carry the level of significance and multiply by 100. As long as it is from 1, it's from 1 to 0, it is significant at 1%. Just write it that way. This is the easiest way I can explain it. Have you written that?
Yes.
Now, let's assume that this p-value here is 0.02. Multiply that 0.02 by 100. What will you get?
That should be 0.2 now.
0.02 multiplied by 100. What will you get? 2. So any p-value you multiply, that the answer is between 2 to 5, it is significant at 5%. Write it down.
Come again.
When you multiply your p-value and the answer is from 0 to 1, is significant at 1%. When you multiply your p-value by 100 and the answer is from 2 to 5, it is significant at 5%. Hey, is this one hard again?
It's not hard.
Hmm?
Then if it's from
It's understood.
Then from 6 to 10 is significant at 10%. Anything more than 10, we don't classify it as being significant, right? We just say it is not significant. So, see, this level of significance during revision, tell me to go over it again, because students usually have issues with it. And the best way I've told you is to multiply by 100 and check which category it falls in. That's the category you take, whether it's at 1 or 5 or 10. If I use the normal one, now it's confusing, because the normal one is from 0.02 to 0.05. It's significant at 5%. That means I'm not multiplying by 100. I did that so that it will be easy. From 0.051 to 0.01, it is significant at 10%. This is the best way I can explain it.
Is it possible for you to help us put on the material significant value?
Okay, remind me, I'll try, because it's not here. So let's move on. What are the limitations of correlation? Correlation is beautiful. So for example, from correlation, we're able to explain to students what is the challenge. Somebody was saying something. So this is one of the disadvantages of virtual class. You interject, and for crying out loud, sometimes when you interject, you cut off the flow. What the person wants to say, the person is unable to say it with the kind of flow the person is supposed to. That's why it's better you mute, because if you are not muted, you can talk not knowing that everybody's hearing you. So limitations of correlation analysis. Number 1, the fact that there's correlation does not mean there's causation. Are we following?
Yeah. Yeah.
That's right, yes.
Correlation does not imply causation. That's what we're trying to say. We are trying to say, what we are trying to say is that the fact that we say if you there's relationship between hours that you study your test score does not mean that everybody that studies long is going to pass. That's what we're trying to say. Correlation does not imply causation. It doesn't mean that X causes Y or Y causes X. Are we following?
Yes, ma'am.
Correlation does not imply causation. So it just tells us there's a relationship. We don't know what is causing it. If you go further to say it's, if you read, you must that one. It's you that is saying it is not correlation, because correlation does not imply causation. Are we clear? Another second limitation is that extreme values can distort correlation coefficient. Just like extreme values can distort your mean, extreme values too in correlation can distort the correlation coefficient and then give you a correlation coefficient that is not the true picture. Who is saying something?
What do you mean by extreme value?
Extreme. Were you in the class yesterday?
No, I wasn't able to join the class yesterday because of my gadget.
Extreme values are outliers. So for example, if everybody in this class, their range of salary is from 100,000 to 150. Are you following?
Yes, ma'am.
If there's somebody in this class that earns 5 million, that person has an extreme value. That person's salary is an outlier to the salaries of people in that class. Because you can see that the distance from that person's salary to the other people's own is far. So that is extreme. 5 million is too extreme compared to 150. Are we clear?
Yes, ma'am.
So those are extreme values. So for example, if you have maybe everybody, the highest everybody has scored is 30, and then there's somebody scoring 100. 100 is an extreme value. And that means 100 is an outlier to that distribution. Linearity assumption, if the relationship is not linear, and for you to know whether a relationship is linear or not is when you plot it. If when you plot it, you can say whether it's linear. If the relationship is not linear and you use Pearson correlation, anything you throw into computer must give you an answer. But if it's not linear and you use Pearson's correlation, you know that you have not used the appropriate correlation coefficient for it. So that result is not something that is reliable. And then range restriction, limiting the range of data can affect the strength of the correlation. So if you say, okay, let me just pick from this to this and find correlation, it's not a true picture. Let it be everything. When you limit the range of data, when we say range, you limit what is highest and what is lowest. So for example, if there's an outlier, you now cut the outliers off. They say there's no outlier. You now limit it. That limitation now is not also a true picture. So there's range restriction. Limiting the range of data can affect the strength of correlation. Now, let's move on to regression because we still have a lot to do. At the end of this topic, students will be able to define regression, its purpose, and identify dependent and independent variables. They were able to use OLS to estimate regression equation coefficients and then interpret regression outputs like coefficients, R squared, and F statistics. Test regression coefficients using T statistics and p-value. P-values to assess variable significance, and then you now use regression to predict value of the dependent variable in the future. Regression is a tool used to examine the relationship between a dependent variable and one that is independent. Am I with the class?
Yes, ma'am.
Yes.
So what is a dependent variable? What is an independent variable? Let me give an example. Now, the example we gave earlier on, we wanted to find whether there's a relationship between number of hours studied and test results, isn't it?
Yes, ma'am.
Yes, ma'am.
It is, ma'am.
If we want to find, that one is correlational. If we want to find whether number of hours studied can predict test outcome, number of hours studied, the one that we are predicting, the outcome, becomes your dependent variable. So in this situation, number of hours studied and test results, which will be dependent variable?
Number of hours studied is the independent variable, and the test result
Why the
is the
test?
Is the independent
So when we say
variable.
results, the thing you want to find out about. So in this case, because we say we want to find out whether number of hours studied predicts test outcomes. That test result becomes your outcome, your dependent variable. If the variable you want to explain, it becomes the variable that the number of hours studied. Are we following?
Yes, ma'am.
So your dependent variable is your outcome variable, is your regressant, is your explained variable, is also your response variable, because your dependent variable is responding to the independent variable. Now, in this case, the number of hours studied becomes your independent variable because it is the number of hours studied you want to use to predict the dependent variable. So another name for independent variable is your predictor or your regressor or the explanatory variables, and also covariates. Is that okay?
Yes, ma'am.
Yes.
So we can use any of these words. Don't think that when I want to ask you, I must use dependent and independent so that you understand what I mean. I can use regressant and regressor. I can use response and explanatory of this word. So you must know. It's just like Precious and Nguhe. You must know all precious name. You must know all dependent variable name. You must know all independent variable name. Because today I might decide to call Precious. Tomorrow I might decide to call Nguhe. They are both the same person. Is that clear?
Yes, ma'am.
Why is regression important? Regression quantifies the relationship between variables. It allows for the prediction of social outcome based on data and helps in social theories. So these are the importance of regression. Regression is very easy. Oh, forget everything I'm saying. When we go in now, you now know that it's easy peasy. Forget about the regressor. Just know it. Don't allow it to make you feel like it's one big thing. It's not a big thing, right? How
Yes,
do we
ma'am.
what is the application of regression in social standards? We can use it to measure how socioeconomic status influence educational attainment. So I want to give Mark. If we say we want to use socioeconomic status to influence educational attainment, who can tell me the dependent and independent variables? Raise up your hand. I don't want cross answer. Rosemary.
Ma, please, coming. Okay, socioeconomic status is the independent variable, and the educational attainment is the dependent variable.
Please, let's clap for Rosemary. Let's clap for Rosemary. Is there anybody that is confused about this? Rosemary, you have gotten 2 marks today. I'm not giving
I
any other
wanted to
mark,
raise
but
my hand.
what she has said is
I
correct.
got 4 already.
So what Rosemary has said is correct. We want to find out how socioeconomic status affects educational attainment. So socioeconomic status is your independent variable, while educational attainment is your dependent variable. And let me make this one clear. Please write what I'm going to say. In regression, anything can be M. In correlation, anything can be X or Y. But in regression, your dependent variable is always Y. Please write it down. In regression, your dependent variable is always Y. While X is your independent or independent variable. If you have more than one X, your independent variables. Please write it down. In correlation, there's nothing like dependent or independent variable. We just have X, we just give them names. But in regression, your Y is always your dependent variable. In regression, your Y is always your dependent variable.
Okay, ma, you said in regression, your dependent variable is always Y and your independent is X.
It's always Y. Why your independent X, and you can have more than one independent variable. You can have plenty, you can have 5, 10. It depends on what you're looking at. Can we move on?
Yes, ma'am.
Our second example, analyzing the effect of government policies on social equity. Who can tell me which is dependent and independent? Abu Emmanuel.
Thank God. And government policy is actually the dependent variable. Sorry, is the independent. Why social equity is the dependent one.
Beautiful. So we want to see how government policies affect social equity. All right. I know.
Thank
Okay. So the last example, predicting the likelihood of social mobility based on income and education, which is dependent, which is independent. Let me see. Usman.
Ma?
Usman, I thought you raised your hand up.
Yes, ma, I'm here.
So which is dependent?
Social mobility is the independent. Sorry, then the income and education is the dependent.
No, you have turned it. See, from your own is even easier than the first two. Predicting the likelihood of social mobility.
ma.
based on
Yes.
income and education. So
I
social
just got
mobility
the
is your
question now, ma.
dependent,
Yes.
and income and education are your
Yes, it's the
independent
independent.
variables.
Yes, ma. Yes, ma.
Because it is from income and education, social mobility. So these
Yes, ma.
ones, they are the ones that income and education, they are the ones that will tell us social mobility. So these ones are independent of this. Is this one that depends on these two?
Yes, ma.
Social equity is the one that depends on government policies. Government policies does not depend on social equity. In this place, it is educational and it's socioeconomic status that determines your educational attainment. Are you following?
Yes, ma.
All right.
Sorry, ma.
Thank you. So let's go on. We have two types of regression: simple linear regression and multiple linear regression. In the simple linear regression, you have one dependent variable and one independent variable. So you just have y. Let me see if I can connect my board and write some things on my board. So in this instance, you just have y and what? X. If I connect my board, then they won't be able to see my slides. So I have to remove it. Right? So in this instance, you just have 1, 1. So this is y and this is x. Are we following?
Yeah.
Are we following?
Yes, ma.
Example: to assess the impact of socioeconomic background on academic performance, y, where academic performance is predicted based on parental income or education. So you are picking one. It's either you use income to determine academic performance or you use education. So you just have one X and one Y. In this situation, we call it simple linear regression. And as your level, you will not even do simple linear regression. It's going to be more. So this is the regression equation. Y, can we see? Y, what is Y?
Y is equal to...
What is Y?
Dependent
What is the
variable.
name of Y? What is Y called?
Dependent
The
variable.
dependent variable.
Dependent variable.
The dependent variable is equal to B naught. This B naught is called your intercept. Are you following? What does intercept mean? Intercept is the value of y when x is 0.
Oh God.
Are we following?
This one is choking us now.
We are following.
Let's just go on. So this is your dependent variable. This is your intercept. That is constant. When we say constant, let me explain what this constant means. For example, whether you earn salary or not, you must eat food. Won't you eat food? Whether
Yes.
it's through begging or anyhow the food comes, you must eat food. So that food you eat, regardless of the salary you earn, is this your constant? This constant, that's what I'm saying, that your y is equal to this when this is 0. That means this your outcome, whether you collect income or not, what consumption will be is this B naught. Are we following? Let's assume that
Yes,
this X is salary. This is what you will eat, regardless of whether you collect salary or not. If salary is 0, you will still eat this food. So your Y is equal to B naught when X is 0. Are we following?
Yes, ma'am.
That's the meaning of intercept. Intercept means constant. That's in that whether you collect salary or not, whether X is available or not, that thing must be there. That's why it's constant. So it's your intercept. B1 is slope, is your slope. The slope of X on Y. When you carry out regression, it is this B1 we are looking for. I will give you Y, I will give you X. This is what you will find. And this is what you use to do your interpretation. Let's go on. As we go on, you understand. E, this is your error term. This your error term, explains what happens in the dependent variable that is not explained by this independent variable. Of course, when we say test scores and hours studied, we know that it's not only hours studied that affects test scores. The other things that affect test scores that are not put into this regression, your error term, we subsume it and explain it. Is that okay?
Yes, ma'am. Yes, ma'am.
So our example, examining how income, that's X, affects life satisfaction among various social groups. So we want to find out how your income, X, and Y is life satisfaction. But the truth is that whether there's income or not, there's level of satisfaction that everybody has with income or no income. As long as you are living, that means you are satisfied. If you are not satisfied, you would have committed suicide. Are we following?
Yes.
So the fact that you have not committed suicide, that is the constant regardless of your income. Do I still have this class?
Yes, ma'am.
Yes.
We have also.
Okay.
It's just that
Excuse
this
me.
one, since we started, it's today that the brain is overheating.
Oh my goodness.
In fact,
Okay,
some of
so
us are left. Some
let's
of
do
us are
this.
left behind because
Okay,
of
let's do
network.
this. Let's do this. I can understand that it can get tough sometimes. This is statistics. It's not like I also learned it in a day. If at this point we feel that we have become saturated, can we create another link in the evening when I arrive my destination? So I'm traveling to Abuja, but
Better.
by 6 I should be there. So can we create another link for 7 to 9 p.m.?
Yes, ma'am, we can.
Is this a
Why
consensus
that?
in the class?
It
It's
is.
very okay.
Very okay.
It's okay.
Yes, ma'am.
It's okay.
So I'm going to start over regression again.
Okay.
Are we following?
Yes.
Yes, ma'am.
Please don't argue too much before that class so that your head will not be hot, so that everything will be calm. Don't argue with people, just be calm. I'll go over regression again. So we'll handle regression and then Dr. Ali will take it from here tomorrow. Is that okay?
Yes, ma'am.
Thank you, ma'am.
Yes, ma'am.
All right, so please don't worry, I'll go over it and I'll try as much
By,
as I can to
Johnny
break
Mercy.
it down for you to understand.
by 6, right?
Johnny Mercy.
No, I said I should be arriving by 7. Let me settle into my hotel and then
6 to
by
7.
7.
Johnny
7
Mercy.
to 9.
Okay, 7 to 9.
It's very
Johnny
fine.
Mercy.
We're okay with
So
it like
class
that.
rep,
Very
kindly
okay.
remind Mr. Emmanuel Panachi to create another link for our evening class since we are saturated, because there's no point I move on if people are beginning to feel that their head is heavy. It means comprehension will be very low. Is that okay?
Johnny Mercy.
Okay, ma.
Thank you very much,
Amen.
ma'am.
Thank you. So we'll start over
Johnny,
regression
Johnny
again in the
Mercy.
evening. Amen.
Ma, we
Thank you
like
very much.
Thank you very much, man. God bless
All
you, man.
right.
well,
All right.
life
So,
set free in Jesus' name.
Save
amen. Thank you. So, see us by
guys.
7 p.m.
Save your
All
name.
right.
Okay, ma.
Then
Thank
I
you
will
so much.
send the slides ahead of time so that you can go through and prepare your questions. Is that okay?
That's a very good one, man.
All right. Thank you. So, see us later.
Thank you.
Okay.
Thank you.
Thank
7 to 9.
you.
Okay. Thank you, ma.
Masters.
Good morning, class. Please, I am seeing some new faces here. I don't know whether they are only just observing our class or they are part of the class. I'm seeing for the first time, I'm seeing Medugu Silas for the first time. I don't know whether
Yes.
it's class.
Yes. I'm part of the class, please, sir.
Okay.
Yes.
Okay.
Please. Yeah.
More are still coming.
Yes.
All right.
So,
Yes.
Okay, so if you are aware of people who are joining our class, and then there is a need for part of our community, you can do the needful.
what is that? Hello?
And you will liaise with Desmond. He knows what I'm talking about, sir.
Is to add you to the group.
Okay, please, you
All
can
right.
add me,
So,
please.
see you guys in the evening.
You
be
please
following the
add me there so that I'll be following them. Yeah.
See you all in the
Please.
evening.
Desmond,
Okay.
please come in. It's Chagu.
Please, 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 is it the class rep?
No, this is Chagu.
Shagu, please, you can send me your number on WhatsApp so that I can call you so that you explain the teacher to teacher
Okay,
for me.
okay, I'll post it right away.
Because you want to discuss.
Yes.
Okay. Send me your number, please.